In today's video, we're going to be going over the differences between permutations and combinations, and specifically we're going to be comparing the two with a visualization, as well as going over the relationship between the two. So if this is something you struggle with, keep watching. Alright, so permutations and combinations, what are these? Now, oftentimes when you hear the definition of what a permutation is and what a combination is, you'll hear that, oh, with permutations, order matters, and with combinations, order does not matter. But to be honest, these definitions can be a little vague, especially if you don't have any context of what exactly this means. So let's better understand these definitions with a visualization. So to visualize this, we're going to be using colors, and we're going to be using the colors red, blue, and green. Now let's say we had to find all the permutations and combinations that we can form with the three colors. How would this work? Now let's start with permutations. Now before we get into finding how many permutations we can form, let's rewind a bit and elaborate more on what a permutation is. Now, when they say with permutations, order matters, what this means is that the number of ways that you can arrange a given amount of items is going to matter. So in this case, we are given three colors, right? So when it comes to finding the permutations, we want to find all the ways that we can arrange these three colors. Now, to denote this, we would denote this as 3p3, which means that given three items, find all the permutations that you can form with the three items, basically. Now, one arrangement would be the current arrangement that these colors are in, which is red, blue, and green. That would be one way to arrange the three colors. Another arrangement would be red, green, and blue, okay? And ultimately, we have 6 different ways that we can arrange these three colors. And if you look at each group, as you see, each arrangement is different. So therefore, there would be 6 permutations. Now let's move on to go over how many combinations we can form. Now before we jump into going over how many combinations we can form, let's elaborate more on the definition of a combination. Now, with combinations, they often say, oh, order does not matter. But honestly, I feel like that definition is really vague, especially if you don't really know what a combination is. Like, you're basically saying it's the opposite of a permutation, but like what exactly is the opposite of a permutation? So let's elaborate on what that means. So yes, there is some truth to the definition, but I feel like some more detail would be helpful. So when they say that order does not matter, what this means is that we don't care about the number of ways that we can arrange the given items. We more so care about the distinct groups that we can form with the given items. So let's make sense of this and go over all the combinations that we can form with the colors. So to denote this, we would denote this as 3C3, which means that if you're given 3 items, find all the combinations that you can form with the 3 items. Pretty similar to how you would denote a permutation. So in this case, we have 3 colors. Now how many combinations can we form with these 3 colors? In this case, there would just be one combination that we can form. Now you might ask yourself why. So let's just say you weren't really certain. You're like, let's try another combination. Let's try green, red, and blue. Would this work as a combination? Now to answer your question, no, this would not work as another combination because we already have a group that contains those 3 colors. We already have a group that contains the colors green, red, and blue. And this is kind of what combinations is about. When you are considering combinations, you want to ask yourself, do I have a group that contains these items? And if I do, then this is not a candidate. But if I don't, then yeah, maybe this can be another combination. So yes, in this case, this would not work as another combination, and that is why there's only one combination, because this is the only distinct group that we can form with the 3 colors. Now you might argue, well, you said with combinations order does not matter, but the colors are ordered as red, blue, and green. And yes, you got a point. Yes, we have it ordered specifically as red, blue, and green. But I want to note that rather it's ordered red, blue, and green, or green, red, and blue, or blue, green, and red, this all represents the same combination. Because remember, with combinations, we're only concerned with the items in the group, not the way they're arranged. And there you have it. That's basically what a combination is. Now let's say we switched up the prompt, and let's say this time we had to find all the permutations and combinations that we can form with 2 out of the 3 colors. So let's jump into finding all the permutations. So to denote this, we would denote this as 3p2, which means that if you're given 3 items, find all the permutations that you can form with 2 out of the 3 items. So remember, with permutations, order matters, which means we care about the number of ways that we can arrange the given items. So this time we're given 3, but we can only pick 2 to arrange, I guess. So one arrangement would be red and blue. Another arrangement would be red and green. And then ultimately we would have, once again, 6 different ways to arrange the items. So therefore there'd be 6 permutations. And if you look at each group, as you see, each arrangement is different. Okay, now let's jump into finding all the combinations that we can form. So to denote this, we would denote this as 3c2, which means that if you're given 3 items, find all the combinations that you can form with 2 out of the 3 items. So remember, with combinations, we care about the distinct groups that we can form, okay? So one group that I can think of is red and blue, okay? Another one would be red and green. And then lastly, another group would be blue and green. And ultimately, we would have 3 combinations that we can form with 2 out of the 3 colors. Now remember, yes, these colors are ordered specifically, but remember, red and blue is the same thing as saying blue and red. Red and green is the same thing as saying green and red, and blue and green is the same thing as saying green and blue, because order does not matter. It's all the same. Now, let's say you wanted to try green and red as another combination because you still weren't really certain. Now, would this be considered another combination? No, this would not, because we already have a group that contains the colors green and red, okay? Because remember, red and green is the same thing as saying green, red, and we already have that. So this would not be considered another combination. And there you have it. So there would be 6 permutations that we can form and 3 combinations. Alright, so far we've gone over the differences between permutations and combinations, but now I want to transition and go over the relationship between the two. So there is an interesting relationship between permutations and combinations, specifically when you're given the same amount of items and you have to find the same amount of permutations and the same amount of combinations. So basically, for every permutation that contains the same items, it's going to map to one combination. So let's explain what I mean by this. So let's kind of revisit our first prompt where we had to find all the permutations and combinations with all 3 colors. So if you look, we had 6 permutations, right? And then we had 1 combination. Now notice that all of our permutations have the same colors in it. Yes, they're arranged differently, but they all contain the same colors, which is red, blue, and green. And notice that, when we group that, it'll all map to one combination. Okay? Now let's even look at our second prompt where we had to find all the permutations and combinations that we can form with 2 out of 3 colors. So with this one, we formed 6 permutations and then 3 combinations. So with the permutations, what we're going to do is kind of group all the groups that contain the same colors together, okay? Now notice that with each of these groups, it maps to one combination each, okay? Now this makes sense because remember, with combinations, we're concerned with the distinct groups that we can form, right? So, if there's permutations that contain the same colors, of course it's going to map to a distinct group. But I thought this was an important relationship to point out because this does kind of help us understand the formulas when it comes to calculating permutations and combinations. But we're not going to be touching that today in this video. But that pretty much wraps up this video, guys. The purpose was really just to introduce what permutations and combinations are and like the difference between the two and also the relationship between the two. So I know this video didn't really go over how to calculate them, but that really wasn't the intent today. So I hope you found this video helpful. I hope you now understand what a permutation is and what a combination is. And take care.